If possible, compute the following product. If not possible, explain why not. So we can only multiply matrices if the dimensions match in a particular way. So let's take a look at the dimensions of these matrices in the order that they're given. The first is a 3-row, 2-column, or a 3x2 matrix. The next is 2 rows, 3 columns. Now, in order for matrices to be able to multiply together, these two middle dimensions have to match. This is why the order matters. You have to write the first matrix as a 3x2 and the next one 2x3 in that order. So the dimensions do match, so we can multiply them together. Not only that, the leftover dimensions, keeping them in the same order, tell us what our product is going to look like. It's going to become a 3x3 matrix. So now let's go ahead and compute that 3x3 matrix. We'll leave space for a 3x3 matrix. It was 1, 0, 2, negative 1, negative 2, negative 2, negative 1, 3. 2, 0, 2, 3. I think that was a 1. And then another 3. Okay, there we've got our matrices. Now, how do we multiply? So it's a 3x3, which means we've got 9 entries that we need to compute. You can do them in any order. I tend to go along the top row and then the next row and so on. But just to emphasize that you really can do it in any order, I'm just going to randomly pick some spots. I'm going to space these out a little nicer as well. In general, when you're computing matrices, you're going to get in your own habit as to what to do first. But I'm just going to pick them at random and show you that you really can do any entry anytime. So suppose I want this middle entry, the 2, 2 entry. Okay, it's in the second row, so you take the second row of the first matrix. And it's in the second column, so you take the second column and you're going to dot them together. 2, negative 2, dotted with 2, 3. And we get negative 2, and that becomes the entry there. Okay, so we've got that one. Let's pick another one. Just another one at random. Let's pick this entry. Now, where is this entry? It's in the first row and the third column. So we'll take the first row here and the third column here. Rows before columns. Okay, and we're just going to compute the dot product. 1, 0 dotted with 1, 3. We got 1 plus 0, 1. So this entry up here is a 1. Let's pick another one at random. Let's do this one. Where is this? This is in the third row, the second column. So we'll take the third row and the second column here. And we'll dot product them together. Negative 2 plus 9. So this should be a 7. Okay. What should we do next? Well, we can do anything. Let's get the 1, 1 entry. First row, first column. So we'll take first row and the first column. Give ourselves a bit more space here. Of course, feel free to rewind the video if you wanted to take another look at those calculations, but they're just dot products. We've seen dot products for a long time. Let's see, 1, 0 dotted with 2, 0. 1 times 2 is 2. 0 times 0 is 0. So we get a 2. So 2 is our first entry there. Okay, let's pick another one. How about this entry? Where is it? It's in the second row and the third column. So what are we going to do? Take the second row and the third column, and we dot product them together. 2, negative 2, and we read from top to bottom, 1 and 3. So we'll get 2 minus 6, negative 4 for the 2, 3 entry. Let's finish up that column there. Let's do the 3, 3 entry. So I'll need the third row and the third column. -1 plus 9, that's going to be 8. All right, we're slowly filling it in. If you're, wondering, well, why are you choosing the ones you're choosing? As I've mentioned already, I'm just trying to show that any entry can be computed at any time. All right? Usually, and you'll see me do this in other questions, usually I just go along the top and then I go to the next row and the next row. But there's no reason you have to do it that way. Let's pick another one. Let's finish off the second row. So we want the second row, first column. Take the second row and the first column. So we get 4 plus 0, so this entry should be a 4. Okay. Where else to go? Let's do first row, second column. Because I feel like it. 1, 0, dotted with 2, 3. You'll get 2 plus 0, so it'll be a 2. And we only have one entry left to go. Third row, first column. Third row, first column. And that's going to be -1, 3, dotted with 2, 0, -2 plus 0. So we get -2. And there's our 3x3 matrix. That's the end result of this process. Okay, so there we go. We multiplied our matrices, dot products of rows and columns, but it does not matter which order you fill them in, just as long as you take each entry one at a time and you find the appropriate row and column to use for your computation. There you go.